Hey guys, I'm going to be trying to do a brief introduction into K-mapping or Carnot mapping. And what K-mapping is, it's a simplification process that gets you directly from the truth table of whatever it is we're looking for directly to the simplified logic expression. Previously, in the previous unit, we went from truth table, we pulled out all the min terms, and then we took those min terms, put them into an equation in a sum of products equation, but it was unsimplified. Then we would have to use the Boolean laws and theorems and do Boolean simplification to get the simplified equation. What K-mapping does is really a cool process where we can go directly from the truth table, put it into this K-map, and then we can pull out the simplified equation from the K-map. So what I want you guys to do right now is write down in your notebooks these 3 templates. And you can pause this, but what's going to be is a 2 input. It's just a square. And it's going to be not A, not B, B. And then 0, 1, 2, 3. Pretty straightforward. So go ahead and put that in. You can pause this. I'm going to keep moving. The next one we're going to do is a 3 input. And it's going to be this time we do A, B, and then C goes here. A, B's go together. And just like before, we do not C and C. But then this time, it's going to be a little different. We go not A, not B, not A, B. And then this time, we go A, B, and then A, not B. So 0, 0, 0, 1, 1, 1, 1, 0. These two are kind of flip-flopped. And the order's a little different when we number it, too. It's going to be 0, 1, 2, 3, 4 goes down here, then 5, and then finally 6 here and 7 here. And go ahead and write that one down. This is our 3 input. And then the last one we're going to do is a 4 input, right? So this one's going to be similar to the 3 input. And of course, A, B, C, D, and I just write these all out. And I do not. I write all these out. Not. And again, our convention is not A, not B, not A, B, A, B, A, not B. And up here, it's not C, not D, not C, D, C, D, C, not D. And again, our numbering conventions can be even a little funkier this time. It goes 0, 1, 2 in the last column, then 3. We go down a row, 4, 5, 6 in the last column, then 7. Then we're going to go to the bottom row, skipping the third one, 8, 9, go to the last, 10, 11, and then finally we go to the third row. We do 12, 13, jump over 14, and then 15. And what these numbers represent that we've been writing down is where in the truth table the numbers zeros or ones go into this table. So let's do an example. We'll start with a 2 input truth table. We have A, B, and Z. 0, 1, 0, 1, 0, 0, 1, 1, right? Let's do 0, 1, 1, 1. As we know, that's an OR gate. And what we want to do is we want to transfer this to our new K-map. Previously, we would have done this, pulled out not A, B, A, not B, A, B, and we would have done Z equals not A, B, or A, not B, or A, B. And doing simplification, we would have been able to pull out and simplify that. But in this case, we're going to transfer these over. So this 0 goes here, 0. This 1 goes here, 1. This 1 goes here, 1. And this one goes here, 1. Again, we have not A, not B, B. And the process now that we have this set up is that we want to capture as many groups of ones as possible. So the most we could have in here would be 4. And is there 4 ones together? There's not. Next we would look for, it's always going to be multiples of 2, would be 2. Do we have 2 together? In this case, we do. So we circle all the ones with 2. I got this one. And what this equals is, because it's a row, this just equals B. And then I have this. You always grab as many, even if it's already taken. So this one was with this one, but we still want to pull it with this, as many as you can. And this row would just be A. And that would be it. Z equals A and B. A or B. Right? We've circled all the ones. Let's do another one. We'll do a 3 input. A, B, C. Z is our output. 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. Our output, I'm just going to make this up. So now we want to put this into K-map. Again, K-maps always get set up the same way. Not, and then this is not. So now, and remember these correlate, I'm not going to draw the arrows, but this one goes to here. This one goes to here. Remember 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7. All have their place. Use your template when you're filling this out. You can pause if you want to try it on your own, or you can just follow through with me. I'm going to fill this out. I have 0, 1, 1, 0, 1, 0, 1, 1. And that's simply just taking the information from my truth table and plug it into my K-map. Now what I want to look for is, when we have 3 terms, we could have an octet or a group of 8. So do I see a group of 8 anywhere? Well, no, I only have 1, 2, 3, 4, 5 ones. So I don't have a group of 8 anywhere. Do I have a group of 4 anywhere? And groups of 4 could be a line straight down or a box, 4 in a row like that. But I don't see anywhere where I have a line, or a box. These also jump over. So this one could be connected to this guy. This one could be connected to this guy. They can jump over like Pac-Man, if you guys know how Pac-Man works. So ones I see that sit alone, I can usually tackle first. This guy is not next to there, not next to there, not next to here. So he's alone. And what he equals is not A, not B, C. So Z equals not A, not B, C. That's him. What about this guy? He's with him, so I could pull that out. Can't go there, can't go there. All right, so best bet is to do this, pull him out. And now what I have here is not C, and then not A and A, so A doesn't matter, but B stays the same. So this one is just B, not C. Because it doesn't matter what A is doing. Whether A is not A or A, it's still a 1. So that's how that works. Now we have this guy, he's with him. We'll circle him. What we have here is a line. So usually if you have a line, it's just going to be whatever's here. A, B, or A, B. Because up here, it doesn't matter whether C is a 0 or 1. As long as A and B are there, you get a 1. And our last one would be this guy. And even though he's been circled, we still want to circle him again, because we still want to group as many as we can together. And what he would be not C for sure, because it's in this row. And then what's not changing here? A stays the same. B, doesn't matter what B is, it has to be A, not C. And that would be our K-mapping for this guy. Let's do one more. This one we're gonna do a 4 input. A, B, C, D, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 0, 1, 1. Obviously, I didn't do enough. And we got to get our output. And let's just do 0, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0. And again, we're going to build our table. If you guys are watching this at home and you have the availability to watch this in 1.25 speed or 1.5 speed, I would recommend doing that so you don't have to sit here and wait for me to draw this stuff. But again, not, not. That's how we always set these 4 inputs up all the time. And then again, we're going to take these numbers and fill them into this table, going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 into our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just like we have from our template that you guys already wrote down. Always revert back to that template. So some people only write ones, which is fine. I always write them all out, but for the people that only like to write just the ones, 0, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1. I must have messed this up. Apologize. This is why I write the zeros out. 0, 1, 1, 0. 0, 0, 0, 1. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 0, 1. So 0, 1, 0, 1. The last one's 1, 0, 0, 0. Unfortunately, I rushed through that. I was trying to do it without the zeros, but I like to draw on the zeros so I know I'm doing it right. And here is where I want to start to group things. And when you have 4 inputs, you could have up to 16. So if they're all ones, it would be just one hex is what they call it. We obviously don't have any hexes. Do we have any octets or groups of 8? Groups of 8 could be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It could also be 1, 2, 3, 4, Pac-Man style, 5, 6, 7, 8, if they are all together. Or likewise, this way. We don't have any of those as well. So groups of 4, do we have any groups of 4 anymore? That would be a straight line this way, or a box somewhere. And I don't see any of those, so now we want to go to our duplexes. This is the only one I'm seeing. And this would be A, not B, because it's in this row. They obviously don't change. Then we want to find what's the same up here. Here I see not C and C, they changed, but the D stays the same. So this would be Z equals A, not B, D, because it doesn't matter what C is doing. It'll be a 1 either way. Or, and now I don't see any other ways we could simplify this. This would be alone, 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 and alone. This would be AB, not C, not D. And this guy would be not A, not B, not C, D. This guy would be not A, B, C, D. And this last one would be not A, not B, C, not D. And that is the most simplified that we could do this equation, or this truth table. Now, let me give you a better example where we start to have some simplification. Just doing this. Here you can see we have a bunch of groupings. We would have to correlate to what this would look like over here. This would just be 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1. And now what we want to do is get the simplified equation for this guy. So, do we have a group of 16? No, we don't. Do we have a group of 8? Some of you may say, no, we don't have a group of 8, but we actually do. I did this on purpose. This guy is combined with this guy. 1, 2, 3, 4. Over here, 1, 2, 3, 4. So we have to figure out, what do these all equal? Well, what's the same up top? Not C, not D. C, not D. So the only thing that's not changing here would be the not D. It's always going to be not D. Here, nothing changes at all. So this would be not D, or, well, where else? We still have these two guys left. Can we group these in a group of 8? No. Can we group them in a group of 4? We can. So even though these two are still taken care of, we don't want to do a small circle here. We still want to group them in a group of 4 like this. And what this is now the same thing. We want to see what's the same. Well, over here, A stays the same. So I know that A is going to be the same. B changes though, so we won't count that. We look up. C stays the same, but not D changes. So this truth table simplifies to not D or AC. Always make sure you group them even if they've already been grouped. And the last thing that I want to talk about here would be, the Pac-Man style. It can jump up this way, goes to the bottom, or go to the side. Even if these were, both zeros here, we'd still have a group of 4. It might be hard to see, but this guy, this guy, this guy, and this guy would all be grouped together. The more you practice these, the better you're going to get at that. The last thing I want to show you before you guys can start working on your own would be what we call don't cares. And I'm going to use the same example, but I'm going to make this an X, this an X, and I'm going to make these 3 X's. And what X's are, they're called don't cares. And what that means is we don't need to worry about making sure we encapsulate the X's, but if they help us make smaller groupings, we can use them. So again, A, B, A, B, A, B, A, B, not, then C, D, C, D, C, D, C, D, not, 1, 0, 1, 0, 1, 0, 1. This becomes an X, which is a don't care. X, 0, 1, X, and then X, X, 1, 1. So now again, I don't have to worry about making sure these get circled anywhere, but I use them if they help. So I'm going to do Z equals, and do I have a 16? No, I don't have a 16 anywhere. There's not 16 ones. Do I have an 8? Well, I see 1, 2, 3, 4, 5, 6, 7. There's only 7 ones, but with these don't cares, I can actually simplify and still do that same one here, where I see here, not A and A doesn't matter, not B and B doesn't matter. So these don't matter at all. And what stays the same between these two would be just the not D, just like before. Now this is the only other one I have to take care of. It's next to this, so we could do a group of 2, but we can also use these X's and do one group of 4 this way. We could do like what we did before and do a group of 4 like this. That's acceptable. We can't go this way. We can't go this way. But just for, to do something different, I'm going to do it this way. I'm going to group it with these not. And again, it doesn't really make a difference, but again, when we have a whole row, it usually just means it's going to equal this, or A, not B. And that's using our don't cares. So that is K-mapping. I want you guys to kind of work on the activity. Go through the slides. The slides will show you, if you're having troubles, how you can get these comparisons, where these groupings can come from. But at least you have a few examples from me, and I will post solutions. If you're really struggling, I can kind of go through how to do them with you guys. Good luck, and you have the next few days to do this, so take your time, make sure you're doing it right, don't rush through it. Hope everything's going well at home, and I'm really looking forward to going back to work. So let's hope for the best for the situation that we're in.